Hi everyone, and welcome to today's Kublr's online meetup. I'm Terry Shea and we'll be discussing application deployment in Kubernetes. Today's presenters will be Slava Koltovich, CEO of Kublr, and Oleg Adamanenko, one of our senior software developers. We recently started this series, and you can find the previous meetups on our website or on our Bright Talk channel. The reason we call this an online meetup and not a webinar is to encourage you to ask questions throughout the presentation. We want this to be a conversation as opposed to a one-way communication stream. So feel free to post questions, and we'll try to weave in as many as we can. And if for some reason we don't get to your question, we'll get back to you after the meeting. There will be a live demo at the end that Oleg's going to do, so it's not recorded, and sometimes things break, so be patient if that happens, but we're pretty sure we have it down. You'll be able to find the downloadable presentation slides in the attachment tab. And before we get started, I want to tell you a little bit about who we are and what we do at Kublr. Kublr is a platform that enables IT operations people to deploy, run, and manage Kubernetes clusters. It enables you to do it on-premise or in multiple cloud environments, and it builds in a lot of things that enterprises need, like security, centralized logging and monitoring, and integration to backup and disaster recovery. There's a link that you see in the slide on how it works, which is the technical description of Kublr on our website. We also have a downloadable demo if you want to download and try Kublr. So Slava, I'll send this over to you now.
All right, thank you, Terry, and hi everyone. So let's talk about deployments to Kubernetes. And before we start reviewing technical details and technical approaches that we want to present today, I want to take a minute to talk why we even talking about deployments and what we want to achieve from deployment to Kubernetes. So Kubernetes, is known for being scalable and reliable and bringing the scalability and reliability to your apps. So when we talk about deployments, you want to have their deployments stable as well, right? So one of the first thing that we always trying to do around deployments, or you all should be doing, is make sure that when we deploy, your application doesn't break. So and your service doesn't break, which means that whatever we do, we want to support zero-downtime deployments, meaning that it's always response. And we also want to make sure that we don't guess on the deployment and new version quality. So we don't wait for our customers to tell us, hey, your new version doesn't work. We want to be able to verify and test this deployment right away as soon as we have it in production or pre-production environment. We also want our deployment to support frequent deployments or continuous deployment, and that can be anywhere in between, several times an hour or several times a minute to several times a week. But we just want to make sure that the platform, the deployment platform that you establish or we establish, can support any deployment pace that you may want inside your organization or your business may want. And last but not least, we also want to support microservices. And saying microservices here, I really mean a number of applications, right? So when you deploy monolithic application or 2 or 3 of them, you can afford some manual steps, you can afford some command line typing and so on and so forth. When you break it down to microservices, you very quickly get to dozens and then hundreds of them, so you cannot really do it manually anymore. So you need a platform that will help you to make sure that these hundreds of your services are always updated in your environment. It's always working. So we're not going to focus much on CI platforms and other components of the deployment flow, but just in general, this is the way that's a simplified way on how we see different components interacting in the whole deployment flow. Right, so you have a CI platform that actually triggers builds when your code changes. So normally that would listen for commits on your Git repository, start testing or unit testing, will build your binaries, and in the end, because we deploy to Kubernetes, that will build and publish your new Docker image with the service or services that were changed in the code. So the Docker image is published to Docker registry, and today there's plenty of different options on what registry you can use depending on where you are. So if you are on cloud, you obviously you can use the registry provided by cloud providers, so be it Google Cloud or Azure or AWS. If you are on-prem or in more private cloud environment, so there's also on-prem options for this, like JFrog and Nexus repository. And then, when Docker image is published, so that's where your deployment platform picks up, and it listens to updates on, on the Docker registry, on tags or versions, depending on how you set it up. And it's actually the platform or the tool that does the work. So picks up the new image and makes sure that it's consistently deployed to your or across your environment. And again, so we're not spending too much time on continuous integration today, but just to give you an idea. So there's plenty of tools available on the market, free and paid, open source. So GitLab has a tool, GitHub has a tool, Bitbucket have some delivery pipelines, and then there's specific tools like Travis CI, Circle CI, TeamCity from JetBrains. We internally prefer and always recommend to use Jenkins because it's bulletproof, and Jenkins also provides a nice plugin for Kubernetes that simplifies management of worker nodes. So historically, or if you don't have this plugin, the way Jenkins works is that you deploy master node, and then you have to deploy several slave nodes or worker nodes, connect them to the master, and master will distribute builds across those slave nodes. With Kubernetes plugins, the provisioning of slave nodes happens automatically. As soon as you have new build, Jenkins master would start a new worker node, and this worker node would execute this build. So if you haven't tried it yet, so try it. It works just fine and scales well, for your continuous integration. And for deployment, I think as the next step we will review several deployment strategies and the way they are implemented in Kubernetes, and then we will switch to, or they will turn to different tools that can help you to automate it. So we'll start from the simplest one called rolling updates. So the idea is that you have your application running in, let's say, production environment, and then you start a deployment, and there is a mechanism that replaces old version of your application instance by instance with a new version of your app. So, and Kubernetes supports it natively. So with the deployment, with the mechanism called deployment. So that's a high-level controller in Kubernetes that the only purpose of which is to make sure that your deployment of replica sets and your pods go smoothly using roll and update mechanism. So if we look at the diagram, so we have a deployment that we submitted to Kubernetes saying that we need 3 replicas of application B or service B. Deployment spun off another entity on Kubernetes called replica set that is managing your pods. Then we have a service, which is internal out-of-the-box Kubernetes load balancing mechanism that connects a client, which we call here application A, to all the pods that are included into this replica set for version 1. And then when we start deployment of a new version, so what deployment mechanism does, so it's actually span of the new replica set. You can see the, one is labeled as version 1, the other one is labeled as version 2, and then it's slowly or gradually shut down pods in replica set version 1 and starts new pods in replica set version 2, so with the new version of your application. Your load balancer, your service for service B is redirecting your traffic or directing your traffic using round-robin mechanism to all your pods available at this point. So meaning your client may, during the deployment, your client may hit first version of the application or the second version of application, and this is not something you can easily control when it's deployment. So, and when deployment is done, obviously, so when all replicas are started on with the new version, so deployment, Kubernetes deployment shuts down the previous replica set, and the load balancer only directs traffic to the new version, so your clients see the new version only. So that's a great mechanism if you need to easily update your application, let's say in development and QA environment, when you don't really care that much about which version your client hits during the deployment. However, in order to implement it for production environments, you want to make sure that your APIs are, backward and forward compatible. So because you never know where the load balancer will redirect the client request. It also works relatively well with API services, not that well when it comes to, let's say, front-end services. So just imagine that your client hits version 1 that returns style sheet file that refers to an image that does not exist in version 2, and so as the next request, your browser would ask for this image, and this request may be easily redirected to version 2, and so the image does not exist, and then you have a broken UI experience for your client. So that's, I think, one of the efficiencies of roll-in update. The other thing that blue-green deployment solves that roll-in update doesn't have is that really when you start roll-in update, the only thing you can confirm for the new version is that the health checks are passed, right? So you don't have control over testing or anything like that. So deployment will spin off the new pods with new version, will make sure that health checks are fine, readiness and liveness checks are fine, and then will claim or will call this pod live, which means that this pod will receive traffic, so which may not work in some of the scenarios that blue-green deployment intended to solve. So let's start from, talking about blue-green deployment, let's start from the same setup. We have application A calling application B, we have service in between that does round-robin update, and now we need to deploy version 2. So the way we do it in Kubernetes, we actually create a new deployment. So we don't use the deployment update mechanism. We can create a new deployment with the same amount of replicas with the version 2 that will create a new replica set with the new replicas of application, with the new pods of application. And that's the stage where you can test the new version before you actually switch load balancer to it. So the service still only refers to replica set version 1. It doesn't know anything about replica set version 2 unless you or until you tell it through selector. So that's where your application is up and running, but clients don't see it yet. So that's where you probably can run some smoke tests, integration tests, and so on and so forth before you actually switch load balancer. And then when the testing is done, using Kubernetes selectors, just switch the service for application B to the new version 2.0, and it really happens in in half second, quarter of second, momentarily. So your clients will never see the downtime on this. So all the and load balancer is smart enough to handle this. So all the requests that were done before the switch or during the switch will be processed properly. So as soon as it's switched, your request that your client sent will be redirected to the new version of application, and then it's up to you what do you do with the previous one. So you can kill it, so to free up some resources. You can also keep it for some time, to make sure that if for whatever reason you need to go back to the previous version, you can do it again very quickly, quarter of a second without deploying the version 1 back, because you already have it deployed but it's not available. So there are different approaches, as I said, from killing it completely to reducing sufficiently number of replicas to keeping the whole stack. So it really depends on your deployment scenario. Yeah, and in our case, we say, well, if we kill it, so then we have a clean setup and we have only version 2.0 running, and the load balancer balance traffic between different pods on this version 2 application. So the blue-green deployment kind of solves your several running version issues. Also lets you test application a bit before you switch. It doesn't let you test the new version with the actual real traffic from your client. So, and that's what Canary deployments are supposed to solve. So in Canary deployment scenario, again, we start from the same setup. We have one deployment, one replica set, several pods running on it, and then service redirecting traffic or doing round robin between all those pods. Now, what we want to do, we want to, let's say, redirect a fraction of this traffic to the new version. That can be, in a typical theoretical Canary deployment, can be done based on, device of your client, based on whether they are on free or premium subscription, on their location, or just based on some probability. So if you want to redirect some percentage of traffic, so the service will pick up some clients and redirect it to the new version. So the way we do it in Kubernetes without any external tools is that, again, as in the blue-green deployment, we deploy a new version of application using deployment version 2.0. It creates a new replica set, and the replica set is immediately included into your service. So to some degree, it's similar to the way Kubernetes does deployment, so it's similar to the rolling update. So to the degree that you have now both versions up and running and traffic being redirected between two of them. So the only difference is that now you manage how quickly you want to rebalance version 1 and version 2 of your application. So in our case, let's say when we have 2 pods for version 1 and 1 pod for version 2, in Kubernetes that would mean that about 66% of your traffic goes to version 1 and 33% of your traffic goes to version 2. Now if you want to change it, you need to change a ratio of your pods running in version 1 and version 2 on Kubernetes clusters. So let's say now when we monitor this 33% of traffic going to version 2, we realize it works well, so all metrics are fine, requests are processed, and so on and so forth. So now we change the breakdown and leave 1 pod on version 1.0, 2 goes to the new version, and then at the end we completely switch to the new version, so all traffic is redirected to the new version now.
Okay, so Slava, just to recap, you talked about 3 different deployment mechanisms. There's the rolling update, which is a native Kubernetes way to do it. One of the downsides of that is that you wind up with traffic being routed to different versions of the application. And then you talk about blue-green deployments, which, outside of Kubernetes and with Kubernetes are a mechanism to test your application in production, but without live users in a production environment, and then you switch over everybody all at once to the new application. And then Canary deployments, which with other mechanisms can be more refined than what we showed here with native Kubernetes, but they're a way to direct a certain percentage of your live traffic to the new app and monitor it, and then scale it up if it's working, or go back to the old one if it's not. that basically it?
Yeah, that's correct. That's correct. So the only thing, I mean, when we talk about Canary deployment, we all, used to see 99% and 1% and 98% and 2%. So if you really want to get to that level of, of details or of the breakdown, so you have to have at least 100 pods in Kubernetes cluster been up and running, because the only way to manage this percentage using or this ratio using standard Kubernetes mechanism is number of pods running on the new version and old version. So the service that we have in Kubernetes by default does just simple round robin. So there is no way to tell, to tell the servers or make the service to redirect 99% of the traffic to the old version and 1% of the traffic to the new version. And that's something that can be achieved when we add tools like Istio to the Kubernetes cluster. And so Istio is a service mesh built by Google, IBM, and Lyft. And it's based on Envoy proxy, which became very popular, was initially built inside Lyft and then open sourced. And so, Istio is built around this Envoy. And Istio does a lot of different things that you need when you do your microservices deployment. So for today, I think we will focus on traffic management. So there are several control plane components inside Istio that manages how traffic is routed inside the application. So the way Istio works is that your container is actually wrapped by Envoy proxy. So meaning that all incoming and outgoing traffic to your container goes through Envoy proxy, and Envoy proxy decides how your traffic is actually routed. So, when you use Istio, and we will see it later, so there is no service in between your client and server or client and API service. So the Envoy proxy decides which client or which service pod it wants to hit with the next request. And the way it decided, so it does it by taking a routing configuration or traffic management configuration from Pilot, which is one of the Istio controlling mechanisms, and you manage it through deploying those traffic or routing rules to your Kubernetes cluster that is picked up by Pilot and then reconfigured on all the Envoy proxies. So let's look at how the Canary deployment works when we have Istio installed in our Kubernetes cluster. So as I said, there is Pilot, which is controlling mechanism that holds the route rules and that deliver these route rules to Envoy proxy. We have two deployments with version 1 and version 2. We have replica sets. The number of pods doesn't really matter anymore, because through routing rules we can tell Pilot, and it will tell Envoy of the client to direct 99% of the traffic to version 1 of the replica set and 1% of the traffic to the version 2 of the replica set, and that will be done again. So this routing will be done on the client side, so you don't need a service in between. So Istio actually uses services, Kubernetes services, but it's only used as a service discovery mechanism. So let's say you edit 2 more or 3 more pods to version 1 or version 2. So they edit to, through labels edit to your service, and that's what Pilot will discover, that now you have more endpoints, and will reconfigure all the envoys inside the cluster to, make them aware of those endpoints. Now let's say the next step, when you have 1% breakdown, so you did your testing, you monitored your metrics, everything works fine with this 1%, you want to go further with the deployment, you deploy a new routing rule saying, well, now I want to switch or to balance traffic 50-50. Again, number of replicas, number of pods in this case doesn't matter. So on old version, you can downscale to, let's say, 1 pod or 2 pods that will process 50% of your traffic. On the new version, you can spin off 5, 6, 10, 20, whatever your number is pods that will process the rest of the traffic. So it doesn't matter anymore. And then when the version is tested and everything works as expected, so that's where you deploy a new routing rule saying, well, now 100% or all traffic to application B goes to the version 2. So the deployment is done. So, and that's, I think, all on our review of deployment strategy and how we implement them in Kubernetes cluster using standard Kubernetes cluster mechanism and some add-ons like Istio. And I have to say that there is more service meshes available on the market than Istio. So Linkerd was, I think, the first one that is still used. Now then, the same company created another one called Conduit. Then there's a service mesh from Nginx, also very similar to Istio or based on Istio, and so on and so forth. So I think Istio, the Istio is the most known one and most used one, but there are others that are available. So with this, we can move forward and go to Kubernetes deployment tools and see how we actually can implement those strategies. What are the tools for us to implement it? I mean, obviously, you can put some scripting around and do it through command line or Jenkins scripts or Python scripts or whatever you use. We would not recommend this unless you have very specific requirements, because you already have tools available for you, so why would you spend more time to build something on your own and then maintain it moving forward? So let's see what we have available. I think when we talk about deployment, the first one that comes to mind is Helm, right? So Helm is everywhere. Everyone is talking about Helm. Everyone is supporting Helm. So it became a de facto package manager for Kubernetes. Everything you can deploy to Kubernetes today, or almost everything you can deploy to Kubernetes today, is available as a Helm package. So there are repositories of different Helms. I think Bitnami provides tons of different Helm applications and so on and so forth. So Helm became very, very popular. And the reason for it is that Helm helps you to not only to deploy applications, but it also helps to deploy all as one package to deploy all supporting artifacts that you need for this application to work. Config maps, secret files, ingress services, persistent volumes, everything what you need to get your application up and running can be packaged inside one Helm package and deployed and updated at the same time. So, and at the same time, it's also very flexible because you have the way it's done internally, so it's based on templates, meaning that you can, for each deployment of this kind of Helm package, you can provide some of the values from the outside and and manage your deployment this way. It also supports update and rollback mechanisms. So Helm tracks the version of the package that you deploy, and if a new version is available, you can upgrade it, and Helm service will compare it with what you currently have running in your cluster and will only update those artifacts that needs to be updated. So let's say if your persistent volume claim hasn't changed or your service definition hasn't changed, so it will not run any update on it. But if your deployment or replica set definition has changed with the new version of application, so that's where the update will happen. And same with rollback. So as it tracks all the versions, it can easily roll back to the previous one. I mean, as long as application supports it. Internally, Helm uses standard Kubernetes mechanism, which means that if you deploy your application, you really limit it to, let's say, replica set for deployment, which limits your option to roll and update only. So you can do blue-green deployments with Helm, but it's, I think I would call it fighting against the tool, not using the tool to your advantage. So, and that's one of the deficiencies of Helm when it comes to application deployment, that you cannot really do anything beyond roll and update for your app. At the same time, I have to mention that Helm is a command line tool, right? So it's as good as kube control when it comes to scripting and implementing pipelines. So even if you have, Helm package, there are still several steps involved, or you need to rebuild it, you need to deploy it, you need to test it, you need to probably roll back it, and so on and so forth. So that has to be done somewhere, not from command line, but your system administrator. So you have to put some scripting around Helm in order to make it a real deployment tool. So what we, where we found Helm useful is deployment of your infrastructure components. Let's say your application requires RabbitMQ or Kafka, MongoDB, MySQL, Elasticsearch to be up and running in your Kubernetes cluster. So this is something that you don't do a blue-green deployment against, and you don't update every 2 hours. So in best case scenario, weekly, monthly, maybe quarterly, and you want to have a control over this update. You really have people, watching how the update is going on. So that's where Helm can help a lot, because again, you can package all the resources in one Helm package and deploy and update them all together. So that's where it simplifies deployment and upgrades. And for application deployment, so the tool that we recommend and the tool that we like today, or we like a lot, so it's the tool called Spinnaker, initially created by Netflix and then open source, now supported by a huge community, including Google, Microsoft, Red Hat, Walmart, and so the tool was created by Netflix to do Canary releases, blue-green releases, or actually Netflix call it red-black releases if I'm not mistaken. So of their applications into AWS environment based on virtual machines and AWS load balancers. But then Google picked it up and created support for Kubernetes clusters and Docker deployments versus virtual machines. So in Spinnaker is a declarative tool. So you define your pipelines as a set of steps or set of stages that where every stage does one specific action, right? So you may have a stage of building Docker container, even though we would recommend to do it outside of Spinnaker in Jenkins. You can have a stage of deploying, testing, switching to the new version, killing the previous version, sending notification to Slack channel to your team, or before you deploy, maybe running security tests around your Docker image, or connect to your Docker repository to check if this image was validated, and so on and so forth. And so it's also extendable. So you have a lot of stages predefined coming with the out-of-the-box Spinnaker, but you also can create scripts, and you can also call external services, external web APIs, as well as you have out-of-the-box integration with Jenkins, where you, as one of the stages, you can run a Jenkins pipeline to do some work around old version, new version, or both versions, and so on and so forth. So, and one of the things that where Spinnaker really becomes handy is that if you think about those different strategies and what you need to script, so Spinnaker already have it scripted for you, or already have it implemented for you. I'm talking about things like blue-green deployment, canary analysis, and so on and so forth. So you don't need to think about switching your load balancer, increasing number of replicas here and there, doing new deployment, and so on and so forth. So you just pick a proper deployment strategy for your Spinnaker stage, and that's it's up and running for you. It also supports manual decision making. So when you need to, let's say, deploy a new front end, or some of your services to pre-production environment or QA environment, have your QA team look at it and then say, yeah, it can go to production. So that's where you can, organize pipeline to support a manual judgment. Notification, authentication, authorization, it's all out of the box, as well as I said, CI and Git integration with majority of Docker registries, and integration with monitoring tools like Datadog, Stackdriver, and Prometheus for Canary analysis. And so we will For the rest of this presentation, we'll focus on Spinnaker, we'll tell you a bit more about its architecture, and then we'll do a quick live demo to show how that works. And that's where I will pass it to Oleg to tell us about Spinnaker architecture.
Hello everyone. So Spinnaker architecture. This slide is a basic representation of all the microservices that Spinnaker consists of, and I'll just quickly and in short describe what's the purpose of each of them. So at the very first, as a user, you will work with DEC, which is a browser-based UI, and DEC works with Gate, which is an API gateway, and UI and all API callers communicate with Spinnaker via Gate. Then we do have an Orca. Orca is an orchestration engine, and it handles all ad hoc operations and pipelines. Then Orca communicates with Cloud Driver, and Cloud Driver is the microservice which integrates with cloud providers, and it's responsible for indexing and caching all deployed resources. Then we do have Front 50, and Front 50 is used for persist metadata of your applications, pipelines, projects, notifications, so basically it's a storage one. Rosco is a bakery, so this is what Slava said. It used to produce machine images. For example, it will create you AWS AMIs, Azure VM images, or GCE images, and currently it's just a wrapper around HashiCorp Packer. But Spinnaker works on supporting additional mechanism for producing new images. Then Igor is a trigger, used to trigger pipelines via continuous integration jobs in systems like Jenkins and Travis CI. So basically, this is a microservice for integration with your continuous integration tools. And it also allows your Jenkins or Travis CI stages to be used in pipelines. Then Echo is a Spinnaker's event bus, and it supports sending notifications like we're using Slack, or email, HipChat, or just text messages. And it also processes incoming webhooks from services like GitHub, for example. Then the two remaining one are Fiat, and Fiat is a Spinnaker authorization service, and it uses secure users access permissions for accounts, applications, and service accounts. We also have Kayenta, and Kayenta is a microservice which provides automated canary analysis for Spinnaker. And we do have another microservice which is not depicted here, is Halyard, and it is a Spinnaker's configuration service. And users usually communicate using Halyard if they need to modify configuration of Spinnaker. And let me quickly show you how the deployment with Spinnaker is usually done. So as you can see here, so we have a development and QA team. So developers update the source code, so they push their comments to the repository. Those changes are picked up by a continuous integration tool like Jenkins, CircleCI, Travis, or whatever tool you use. As a result of a build, you have a binary artifact. If you deploy it to Kubernetes, it will be Docker container, and those containers, those images published like to Docker container registry. It can be Docker Hub, it can be Sonatype Nexus, it can be Artifactory, or wherever you have. And then Spinnaker looks for changes both from source code repository, if you use manifest-based integration with Kubernetes, or it is notified by container registry about new images available. And then based on those changes and pipelines that you have configured in Spinnaker, it may, for example, automatically update new version to your QA environment in Kubernetes. Then you may have like manual testing of this new deployment by your QA team, or you may have automated tests run against newly deployed version. You may have Canary pipeline which will test if everything breaks or not. and for that one, Spinnaker integrates with Prometheus. So Prometheus can collect metrics from your new version, and Spinnaker, based on the collected metrics, Spinnaker may decide if build is stable and it can be moved to production or just stays where it is. And then as soon as decision is done, it can be, again, it can be manual decision or automatic decision, Spinnaker can update your production environment. It's all done automatically. You don't have any configuration drift, so what you have defined, that will be done. So no user involvement into the process. And now let's switch to the demo. I'll start a screen sharing. Okay. So for the purpose of the demo, I have two clusters created. One which is used for QA, it's called Spinnaker, and another one is Spinnaker Production. It will run our production application. Currently, I have deployed application, simple application. It just shows hello world. So this one is our QA environment, as you can see here, Spinnaker, and another one runs in production. So it's two different clusters, two different versions of application. So I do have my source code, which is pushed, stored on the GitHub. I have created webhooks between GitHub and Docker Hub, so all my changes are automatically picked up and configured to build. So I have automatically new build available as soon as I push the code. And I have configured webhooks, so Docker Hub will notify my Spinnaker about new version when new version is available. And now let's go to the Spinnaker itself. So this is how Spinnaker looks like, in case you didn't have a chance to look at it previously. So I have my application called Spinnaker Demo, and I have defined a few pipelines. I'll show you to you how they work. So I have three pipelines. One is deploy to staging, another one is validate staging, and the third one is promote to production. So deploy to staging is triggered automatically as soon as I have update in my repository in my GitHub when definition of my deployment changes. Or I also have another trigger, which is triggered as soon as I have a new version available in Docker Hub. And after it's done, I'll just deploy it in Spinnaker staging, new version of the application. So let's take a look how it works. Again, I have this source code checked out. I already did changes, but did not commit it yet. So these are my changes. I just want to change color from blue to green and set a new version. So let's commit it. Okay. Okay. Content. Update. Background. Okay, and let's tag new release. Okay, it's done. So let's go to GitHub, and we will see that now we have a new commit done. Let's go to Docker Hub, and we will see that we have a new version available. So let's focus only on release builds, so cancel this one, we don't need it. So it will take a few minutes to build a new version of the image. And in the meantime, I'll show you next stages and what's going on. So next stage here is validate staging, and this one is a simple pipeline for the purpose of the demo. It's just a manual judgment. So I'll have to manually check if I'm okay with the release or not. And if I'm okay, I'll just decide, okay, I'm okay with the release, let's continue further. And third pipeline that we have here is promote to production. And the trigger for this stage is configuration that if my pipeline validate staging finished successfully, then I'll trigger this pipeline. So as soon as I decide, okay, this works as I expect, I approve the release, and this pipeline triggers automatically, and what it does is it updates our production. So we see, okay, production account and with the same version of the application. Let's take a look here what we have. Okay, still building, so we need to wait a couple of minutes.
And Oleg, when you are using Docker Hub and the webhooks from GitHub, that's just one way you could do this, right? So if this was a large enterprise, you would have other tooling that you might use, like Jenkins, and have it automatically pull, and the same Spinnaker would detect the same sort of changes regardless of where your registry is, and go through the deployment process you're showing. Is that right?
Yes, correct. For Spinnaker, it doesn't matter who built the image, so it provides you just integration point, and it doesn't matter for Spinnaker where your Docker images are stored or who built them. So you can use the tool that is convenient for you. So we here, internally, we use Jenkins with Kubernetes plugin because it provides us a lot of additional features that other tools cannot provide to us.
Yeah, and while we're waiting for the build to complete, there might be other stages in the pipeline. Like I know people frequently do container scanning before they put it into a final registry that gets pulled automatically, right?
Yes. So, for example, if you do a build, so you can do it as part of your continuous integration. So it may be just an additional stage in Jenkins to do image scan, and there are tools for image scanning already. So one of the most popular one is called Claire, C-L-I-A-I-R, Claire. So it integrates with vulnerabilities databases, so it knows which versions are vulnerable and which are not, and it can scan your Docker image layer by layer and make a decision if, then check if you have vulnerabilities in your Docker image, and then you may have a decision if one of the steps when you decide if you want to promote the build your Docker image to production or not is based on the results of that one. So okay, there are like critical vulnerabilities in the image, so I'm not going to push it into production. I'll just wait to fix.
Yeah.
You can also do the same on Spinnaker. So Spinnaker supports, for let's say external repositories. So Spinnaker can call external API. So there is a mechanism for that, and then analyze response, be it just text, number, or JSON. And from that response, you can identify if the image is validated or not, and so decide whether your pipeline should continue or fail.
Okay, so as we can see here, our webhook from Docker Hub was just triggered, so our deploy to staging was succeeded. So we have a new version, so let's update it. And okay. Looks like, yes, it's here, and not here yet. Oh, it was the latest one. Okay, let's run outside.
Yeah, we're in a conference room here in Washington, D.C., and you may hear some background noise as the rain comes pouring down on the roof, so apologize for that if it's a little noisy. How's the build going, Oleg?
Take a look. Still shows us good.
It seems like you got one done and you're waiting on another one right now?
Yeah.
While we're waiting, there was one question from the audience that popped up on the Spinnaker declarative pipeline. It says, can you show how one can use the Spinnaker declarative pipeline? I don't know if that's something that we can show during this.
So for declarative pipeline, so each of the pipeline, as you can see here, so here it's just a UI, but it is available to configure this as JSON. So your pipeline can be configured as a set of JSON files, and you can configure whatever you want to do.
Yeah, but it's also when you go to Spinnaker, I mean, you don't have to. I will try to create a new pipeline to break this one. So when you create one, so that's where you create a declaration of pipeline, and then what you have to define is that first of all you have to define your triggers, right? So how your pipeline is started, and there are several types of triggers, as you can see here. So Docker registry in one of them, changes in the Git repositories, the other one, Jenkins, Travis, the other pipeline, as we have in this demo, pops up. I think it's Google pops up, right? So you can subscribe for messages, and then when messages delivered, the pipeline will start, and so on and so forth. You can also define parameters, meaning that every time pipeline starts from manually or by external or by using API, let's say, so you can provide parameters on how to run it. There's expected, I mean, that's a bit, and then you define your stages. So, and that's where you, as I mentioned, you create your steps. So you can see that there are a number of steps available out of the box for your pipelines. And so we are here using deploy manifest pipeline. You can also arrange steps. Let's say if you have another stage, you can say that this stage really depends on deploy manifest, or you can do it in parallel this way, saying that, if you deploy a couple of manifests, you can say, I want to do it in parallel. I don't need to wait for one to complete before I start the other one. And then you create the third stage, and you can rearrange it, to depend on the previous two, and so on and so forth. So that's how you define your pipelines. And there is, if I'm not mistaken, there should be, manual judgment, something that we demonstrate, run the other pipeline, scale, rollout, wait, webhook. So there should be scripts somewhere as well where you can say, just execute this script or just execute this Jenkins pipeline. So those are the options too.
Okay, great.
Yeah, and as you can see, our webhook just triggered, so we have notifications that it was done. And here we see it's a success. And now if we go here, so we have our new version deployed, so it's version 3, and our production continues to work with version 2. And now going back, so we have to verify, okay, check everything looks good. So I agree to continue. I validate the staging, I click on continue, so it's manual judgment. Okay, it's done, and now we can see that promote to production is currently running, and in a few seconds we will see updated version here. So it's validate staging is running, succeeded. Let's take a look. Not yet, almost there. And in addition to we need to close this.
It seems that you triggered another set of another stream of pipelines with the old version as well somehow. I mean, during the demo, so that's why you have to do it twice. So now it should be done.
Okay, succeeded. Yes. Yeah. Now production is upgraded, so we have version 3 here available, and you can see all the so all your changes through the pipelines. So they are all recorded. So here in the UI, you can see different versions and history of changes. What was done for audit, it's very convenient.
Well, that's great. Thanks, Oleg. And there was a quick follow-up question from the person who asked about the declarative pipeline, asking if the JSON file can be stored in a Git repository similar to a Jenkins file.
Well, you cannot store the pipeline definition in GitHub yet, but you can store manifest definition for your deployments. Let's say if you deploy your application and then you have deployment that you want to use with specific parameters, resource limits and so on and so forth, and then you have config map that you want to deploy, and then routing rules that we discussed before, and so on and so forth. So those artifacts can be stored in GitHub repository. It's actually stored in the demo GitHub that you can look at. I think it's public. It's public repository that we put together. So you can store those manifests that your pipeline consists of or that your pipeline uses. And so when those are changed on GitHub, you can also set up trigger in Spinnaker, so you don't necessarily have to trigger your pipeline just by only, let's say, Docker image change, but also if you change the deployment manifest, you can trigger your pipeline automatically. So, and Spinnaker will go to GitHub or Git repository and will take the new version of manifest for next deployment.
Great.
So, thank you, Oleg, for TMI. I'm switching back to slides. Let's see. So, the demo that we shown was, of course, a bit simplified. We need to keep the time. So, what the next step? As a next step, a couple of things you could do, to enrich it and to bring it closer to actual production deployment. So one of them is to connect your Spinnaker to Prometheus, and so as soon as you do it, you will have a Canary analysis stage available, meaning that in this scenario, if you deploy a new version before you kill the previous version, you can actually do a Canary analysis using Spinnaker and Prometheus automatically, and they will decide whether your metrics are deviating from baseline that you set up, and then you decide whether this pipeline should or deployment move further or actually roll back. And if you want to do the real Canary deployment with the flexible traffic routing based on clients, subscription, percentage, and so on and so forth, you need to deploy Istio to your Kubernetes cluster. And to also add to this, so I think Terry mentioned Kublr as our platform at the beginning. So very soon we will release some preview of Spinnaker package on top of Kublr that will out of the box integrate with Prometheus that we have deployed as a part of the standard package, as well as to identity provider, so be it your Active Directory, LDAP, or anything else you use, so that you can assign permissions and roles inside your Spinnaker on who can run what and who can deploy what. So that's coming.
Okay, so that's great, Slava. Thank you. And in terms of questions, one of the questions in the chat was around what type of applications would you say are better for blue-green or better for Canary, or when not to use either? I know you commented on it during the presentation a little bit about how, if you didn't have an image available in the second version, it could be bad for having two versions running simultaneously. So there are clearly cases where you might prefer a blue-green deployment. But do you want to comment on applications and?
Yeah, sure. So I think that, as I mentioned, the roll and update, if you do roll and update or Canary release as well, so when you have two versions up and running side by side, you really want to make sure that you have, backward compatibility on your API or, on your request, basically, because if you use Istio, you can guarantee that the same client will always go to the same version of application. But if you use just a standard load balancer, like in blue-green deployment, for example, you cannot guarantee that. So you really want to make sure that they are backward compatible. At the same time, stateful applications do not work well with blue-green and Canary releases, right? I mean, you don't want to have two versions of your application accessing the same data store. I mean, just imagine, Elasticsearch replica with three replicas, two of them have one version and the other ones with other, and so on and so forth. So that can be a disaster. And so For a stateful application, I would say the roll and update is probably one of the best options. You can do Canary releases and you can do blue-green releases or deployments, but that would require some additional work to make sure that those two different versions do not, do not break your data repository.
Sure. Okay. And in terms of Istio, what you talked about here was really focused on routing, but you did mention that as a service mesh, it's used for broader purposes around microservices. One of the questions was, in terms of Istio, what other capabilities exist that make it useful for microservices architecture?
Yeah, so there's a lot of tasks that you have to solve, or a lot of things that you need to provide when you do a real microservices deployment. Right, so authentication, authorization between services, debugging and tracing, so who calls what and how the overall transaction went and so on and so forth. Circuit breakers, so that to make sure that your services do not call each other in a circle, repeats, failure thresholds, and many other things. So that's all the functionality that provided by platforms like Istio that you don't want to implement inside your applications anymore, because you can just basically plug it in and use.
Great. Well, thank you. So we're a little over an hour now, and we're going to close it out. I want to thank everybody for coming to today's meeting, and feel free to reach out with questions, topics, or suggestions. You'll receive an email that will also have a link to the replay. So we noticed that several of you joined a little bit after the meeting had started, so feel free to look at that as well. And once the meetup ends, you'll be asked to provide feedback. So please do share your thoughts, as this will help us improve our future meetings. And our next meetup will be announced shortly. We hope you can join us again. Thank you.